Dear students, last time we discussed types of integral equation, and this time we discuss convolution and other form of convolution which use in integral equation. Let us see this lecture. The content of the lecture is integral equation of the convolution type. Second, iterated kernel or functions, Leibniz rule of differentiation under integral sign, and important formula for converting a multiple integral into a single ordinary integral. So, this lecture is dependent on the kernel of a function. So, how we use kernels to solve the differential equation, integral equations, and what is the formula? The formula which we want to discuss is conversion of multiple integral into a single integral. So, myself is Dr. Amanpreet, postgraduate department of mathematics, Khalsa College, Patiala. Let us see. So, integral equation of convolution type. So, we want to discuss this integral equation of convolution type. So, consider an integral equation in which the kernel x t is dependent solely on the difference. Difference is x minus t. So, k x t is equal to k x minus t, where k is a certain function of one variable. Then integral equation becomes this integral equation. So, students, last time ਜਿਹੜਾ ਅਸੀਂ ਡਿਸਕਸ ਕੀਤਾ ਸੀ ਇੰਟੀਗਰਲ ਇਕੁਏਸ਼ਨ, ਉਹਦੇ ਵਿੱਚ ਇਹ ਇੰਟੀਗਰਲ ਇਕੁਏਸ਼ਨ ਦੇ ਵਿੱਚ ਇੱਥੇ ਕੋਮਾ ਹੁੰਦਾ ਸੀ ਸਾਡੇ ਕੋਲ, ਬਟ ਹੁਣ ਕੋਮਾ ਦੀ ਜਗ੍ਹਾ ਤੇ ਇਹ ਆ ਜਾਏਗਾ k x minus t. This is the Volterra's integral equation, and yx is equal to fx plus lambda from a to x integral k x minus t yt dt. So, this we want to discuss in this lecture, and then come to the next, and next one is yx is equal to fx plus lambda a to b. So, this is the Volterra. First one is Volterra and second one is Fredholm integral equations. Now, are called integral equations of convolution type. Why we say it is a convolution type? Because k x comma t is replaced by k x minus t. So, is called difference kernel. K x minus t is called difference kernel. And let y1 and y2 be two continuous function defined for x greater than equal to 0, then the convolution or plotting of y1 y2 is denoted by this y1 star y2. y1 star y2 is equal to 0 to x integral y1 x minus t y2 t dt, and when this convolution happens, so convolution, what the convolution do? Convolution take this y2 here and x y1 here. So, just see y1 t and y2 x minus t. Lower section ਦੇ ਵਿੱਚ ਵੀ ਅਸੀਂ ਜਿਹੜਾ ਹੈ ਉਹ ਇਹਨੂੰ ਡਿਸਕਸ ਕਰਕੇ ਆਏ ਹੋਏ ਹਾਂ. So, next is are called convolution integral. y1 star y2 for singular integrals, this is minus infinity to infinity, either this is the Volterra's integral equation, or this is the Fredholm integral equation, or singular integral equation. The thing remains same, y1 convolution y2. So, y1 x minus t y2 t dt is changed with y1 t and y2 x minus t. So, next part is iterated kernel or functions. Consider Fredholm integral equation of the second kind. Yx is equal to fx plus lambda from a to b kxt yt. So, this is a Fredholm integral equation. The iterated kernel k n x t, n from 1 to n are defined as below. K1 xt is equal to kxt, and kn xt is denoted as is equal to a to b kxz. This is a triangle inequality. We use this triangle inequality kxz into kn minus 1 zt dz, where n from 2 to 3, 4 and so on. Similarly, if we have Volterra's integral equation, so Volterra's also deal the same thing, but here now the limit is variable. So, the remaining thing is same. So, k1 x t is equal to k x t and k n x t is equal to t 2 x k x z k n minus 1 z t dz. So, last time we also discussed this Volterra's Leibniz rule of differentiation under integral sign. So, this time for the repetition of this result, and we use this result in this video also. So, I repeat this in formula: d of differentiation under the integral sign is equal to g integral from g x to h x and partial derivative of the function plus f x h x, the upper limit, into derivative of upper limit with respect to x, minus f x lower limit and derivative of lower limit with respect to x. So, students should will be very careful while using this results, because this first exercise or the first and second exercise, we use these Leibniz rule of differentiation under integral sign so many times. So, let us start. The next one is an important formula for converting a multiple integral into a single ordinary integral. So, this formula is very useful while we simplify the numerical questions. An important integral formula for converting multiple integral into a single integral, and the integral is a to x y t dt raised to the power n. This n means this is a multiple integral, and how many multiple integral? N time multiple integral, which convert into single integral a to x x minus t. X minus t, as we discussed earlier, this is the kernel and kernel of difference, x minus t raised to the power n minus 1 over n minus 1 factorial y t dt. And let us see the proof. Proof is, let in is equal to a to x x minus t raised to the power n minus 1 y t dt, where n is the positive integer and a is the constant. So, I take this integral as a first number. Differentiating one with respect to x using Leibniz rule, as we discussed earlier just now, ਹੁਣੇ ਅਸੀਂ डिस्कस ਕਰਕੇ ਹਟੇ ਹਾਂ ਕਿ Leibniz rule ਕੀ ਹੈ। Leibniz rule ਨਾਲ ਅਸੀਂ ਇਹਨੂੰ differentiate ਕਰਾਂਗੇ under integral sign. So, this integral sign, this is n minus 1 a to x, derivative of this x minus t raised to the power n minus 2 y t dt as such, plus x minus, this is f of x minus h x. So, x minus h x is here x, and into derivative of h x with respect to x, minus x minus g x, and g x is 0. So, 0 raised to the power n minus 1 y 0 d 0 by dx. So, this becomes 0 because derivative of 0 with respect to x is 0. So, I got d n x or d I n over dx is equal to n minus 1 into I, this is I, n minus 1. So, this is iteration integral, and I take it as a second number reduction formula. So, I1 is equal to a to x y t. So, I d of d I of dx is equal to just a simple derivative, and integration cancels. So, we got y x is equal to, take it number 3. Now, differentiating 2 with respect to x successfully k times. ਹੁਣ ਅਸੀਂ ਇਹਨੂੰ k time differentiate ਕਰਾਂਗੇ. k time differentiate ਕਰਨ ਦਾ ਮਤਲਬ ਇਹ ਹੈ ਕਿ first time differentiate ਕੀਤਾ n minus 1, second time differentiate ਕੀਤਾ n minus 2. This is the reduction formula, and we use reduction formula result. So, n minus 1, n minus 2, n minus 3, n minus k into I, n minus k, where n is greater than k. And using this formula, for n is equal to k is equal to n minus 1, I got n minus 1 d n minus 1 I over dx raised to the power n minus 1. So, this is n minus 1 this sign n minus 1 factorial into I1 Differentiating 5 with respect to x and using 3, we obtain d this using this in 4 I got dn over in dx raised to the power n is equal to n minus 1 factorial into 5x. So, when we got this from 1, 4 and 5, 1, 4 and 5, it follows that in and its first n minus 1 derivative all vanishes when x is equal to a, and hence using 3 and 6, using 3 this one and 6 this one, I got I1 x is equal to a2x yt1 dt1, and then I2 is equal to a2x I1 t2 d2, and I1 means a2x yt1 I dt1 and dt2, and similarly proceeding like this, and when we proceed like this, in becomes n minus 1 factorial a2x, then a2tn, a2tn minus 1, a2t3, a2t2, and yt1, dt1, dt2, and so on, dtn minus 1, dtn. So, this result combining with 1, I got a2x, this one a2x, a2t1, a2tn minus 1, a2t3, a2t2, yt1, dt1, dt2, d3, 3 and so on, dtn minus 1 dtn is equal to this n minus 1 factorial goes to that side, left hand side, n minus 1 factorial a2x x minus t raised to the power n minus 1 by t dt, and then this integral we write in this form, this multiple integral we can write in this form. Just see this multiple integral we can write in this form, where t raised to the power n means its nth integral, n integral, and is equal to a2x x raised to the power t n minus 1 y t dt over n minus 1 factorial into y t dt. So, this we got the formula, and student should remember this formula very carefully. a2x yt dt raised to the power n, a2x x minus t raised to the power n minus 1 factorial yt dt. If I have t square, then this becomes x minus t raised to the power 1 over 2 minus 1 factorial. If I have 3 here, this means x minus t raised to the power 3 minus 1 2, and so this is our result. Now, come to how to use this result. So, first example is there, show that the function yx is equal to 1 plus x square raised to the power minus 3 by 2 is a solution of Volterra's equation. This equation, Volterra's equation, where we have x as a variable, limit as variable, yx is equal to 1 over 1 plus x square minus 0 to x t over 1 plus x square yt dt. So, what method we adopt here? We use it again and again. Here, solution, given integral is yx is equal to this, where yx is equal to, under this sign, this is 1 over 1 plus x, given yx is equal to 1 plus x square raised to the power minus 3 by 2. So, I take yx as yt. So, when I take t here, so this x is replaced by t, and it becomes 1 plus t square raised to the power 3 by 2. So, it is my advice to all students that note this step very carefully, and yx is given, and whenever yx is given, we convert into yt, and when we convert into yt, and then we replace this yt in the given equation yx, and that is all. This is the only way we solve this question. Right hand side is equal to 1 over 1 plus x square, minus 0 to x t over 1 plus x square, and then we have y t, and y t is replaced by 1 plus t square raised to the power minus 3 by 2 dt using 3. So, now it is a simple integration, and integration means 1 over 1 plus x square minus 1 over 1 plus x square, because it is a constant, t into 1 plus t square raised to the power minus 3 by 2. I put t square is equal to u, 2t dt is equal to du, and this integral is now 1 over 1 plus x square minus 1 over 1 plus x square into 1 by 2, and simple integration 1 plus u raised to the power minus 3 by 2 plus 1, that becomes minus 1 by 2 minus 1 by 2 from 0 to x square, and when we put x square and x square, this becomes 1 over 1 plus x square raised to the power 1 by 2, and when we put 0 it becomes 1. So, on simplification these two, we got 1 plus x square raised to the power minus 3 by 2, which is nothing else, which is yx. So, yx left hand side is equal to right hand side. Now, come again, show that the function yx is equal to x e raised to the power x is a solution of Volterra's integral equation. Now, this is again Volterra's integral equation, and here yx is given. So, this equation we want to solve, and first step is same, the same step is, I repeat again and again, take yx is equal to x e raised to the power x as given, and yt is equal to t e raised to the power t. So, just replace here yt with t e raised to the power d e raised to the power t into dt, and then this becomes sin x plus 2 0 to x cos x minus t t e raised to the power t. So, t I take common out, and this how to integrate t e raised to the power t cos t minus x. In the first lecture, very first lecture, we see this formula, and the formula is e raised to the power a x into cos b x plus c. So, this formula is e raised to the power a x over a square plus b square cos b x plus c plus plus sin bx plus c. So, this we apply here t as such, integration of this bracket integration is e raised to the power t 1 plus 1. So, it becomes 2 cos t minus x plus sin t minus x, and the limit is 0 to x minus, now this function as such, and derivative of t is 1. So, we use product of two function for integration. Now, this sin x minus 0 to x e raised to the power t cos t minus x dt, and this integral we find that 0 to x e raised to the power t cos t minus x plus sin t minus x. So, this is sin t minus x, and then it becomes sin t minus x cos t minus x. After putting the limits, we got sin x plus x e raised to the power x minus e raised to the power x minus 1 by 2 cos x minus sin x, again minus e raised to the power x by 2 minus 1 by 2 sin x minus cos x. So, simplify this line, we got x into e raised to the power x sin x. So, it is very much clear that student must require strong integration base to solve this type of integral equations. So, one more question is there, and that is, show that yx is equal to cos 2x is a solution of integral equation, and this integral equation is where kxt, this is Fredholm integral equation. Why Fredholm? Because both the limits are constant. So, kxt is equal to sin x cos t, 0 is less than x is less than t, and cos x sin t, t is less than x is less than this. So, general equation is this, and k, that is kernel, is given by this. So, First of all, y-x is equal to cos 2x, and our first step is put x is equal to t. So, I got y t is equal to cos 2t. Now, the limit is 0 to pi. So, first of all, I change the limit from 0 to x and x to pi. 0 to x, the kernel becomes cos x into sin t. Student, it should be very carefully noted that the limit of t from 0 to x and 0 to x, it is cos x sin t into yt. Yt is nothing else, this is cos 2t, and from x to pi, the result is kernel is sin x into cos t cos 2t dt. So, again here the explanation is required. So, I want to discuss this again. First part is 0 to t, x from 0 to t, but I required integral from 0 to x. What is 0 to x? So, 0 to x, when we take 0 to x, just see 0 to x, this is 0 to x. So, 0 to x, the value of kernel is cos x into sin t. So, cos x into sin t, and similarly when I have x to pi, the kernel value of kernel is sin x cos t. So, this we put here. Now, it is a simple integration. Cos x is constant, so I take it common. So, here sin x is constant, so I take common. The rest is simple integration of trigonometrical function. So, student can do it very easily. Here this is multiply and divide by 2. So, 2 cos previous, just see this here, just multiply with 2 and divide by 2, 2 cos 2t sin t. When I have 2 cos 2t sin t, then the formula becomes sin 2t plus t minus sin 2t minus t, that is sin 3t minus sin t plus 3 by 2 sin x, and similarly here we become cos 3t plus cos t, and then by integrating sin 3t becomes minus cos 3t by 3, and minus sin t becomes plus cos t from 0 to x. Similarly here बस इनू इंटीग्रेट ही करना असी इन्ना ही साडा काम है, और इस तो बाद असी सिर्फ वैल्यूज़ पुट करनी है, लिमिट्स की वैल्यू पुट करांगे, टी नू पहला एक्स पुट करांगे और फिर टी नू 0 पुट करांगे विच माइनस द साइन. ओके, हेयर वी पुट पाई फर्स्ट एंड देन वी पुट x. So, sin 3 pi and sin pi 0. So, we have minus sin 3x and minus sin x. On simplification this, or multiplication and simplification, we get cos 2x, and cos 2x is equal to yx. So, this is the result. So, now the exercise is there. Simple yx. For first question, yx is equal to 1 minus x. So, what is yt? Yt becomes 1 minus t. So, put values of 1 minus t here and just simplify this integral, you got answer. Here in second question, yt is 1 by 2. So, this is 1 by 2, and if any student has any problem in the exercise, they can put any question to me, or I will send the PDF file of the solution of each and every question. So, student, do practice. If you have any doubt, you can contact me. Thank you.